Good morning. Welcome back to our channel ALP Talks. This is your Lakshmipati. Today I came up with one good topic. This is explanation to IS 2026 power transformer standard in India. Yes, whoever the people dealing with transformers in their day-to-day task, it may be utilization, it may be servicing, it may be manufacturing, it may be designing, it can be anything, any task related to the transformer, maybe estimation of cost, maybe estimation of overall weight, or whatever it may be, mechanical designer. Yeah, there are hundreds of thousands of people will come into this picture, but they don't know that. Yes, there is no need to know everybody, but yes, it's better to know few things so that they can be better aware of all the situations, so that they can better handle the situation. They can get promotions also if you are there clearly handling the every situation. So what are the different things in the standard? Because only I think mainly designer knows most of the things about the standard. The many people, they don't bother about it because they don't want to know these stuff. But yes, it's better if they also know some minimum stuff. So that's why I'm explaining each parameter, the importance of each parameter. So clearly go through this explanation. I hope it will enhance your knowledge how to utilize each word in this standard. Yeah, please keep watching. How to download IS 2026 from internet from government approved sources. Please watch my previous videos. I just took the downloaded IS 2026 standard into other tool so that I can explain something to you with a pointer. Yes, this is what power transformer general standard. There are other standard also. You can I'm just going through this power transformers, power plant general. Yeah, this is what maintaining. If you need any hard copy, you can purchase from here. Power transformer committee. Yes, this is what just forward. They may just maintain some things here. Temperature rise is part 2. Installation level, dielectric test is part 3. Terminal markings, tappings and connection, part 4. Ability to withstand short circuit, part 5. Loading guide for oil filled power transformers, part 7. Application guide, part 8. Determination of sound levels, part 10. So something like that, we have every part for every aspect. So we are going to discuss every part in detail in our coming future slides or future videos. It may take more time, but stay connected, keep watching. I hope it will be a good input to you. Yes, there are different things, you can just go through it. So we entered into the standard. This part applies to 3-phase and single-phase power transformers, including auto transformers. Yes, there are certain limitations. It's difficult to cover everything into the standard, but the standard discusses mostly general aspects related to every transformer. But yes, certain transformers may be due to some stringent conditions, those won't fall into this category. This section is about the scope of the transformer. You can see here, for example, some special transformers and very small transformers. Single-phase transformers with rated power less than 1 kVA or 3-phase transformers less than 5 kVA. Very small transformers 1 kVA or 5 kVA, those won't fall under IS 2026. But yes, some clauses we can apply for that, but entire IS 2026 all parts it won't apply for that. Instrument transformers such as current transformer, potential transformer, for those we have a separate standard. Here we have static converters. We have transformers for HVDC converters, and for those we have a separate standard. Transformers for traction. In railways and all, we have more transformers. In metros and all, some little small transformers will be there, some 1000 kVA to 3000 kVA, something like that. It may extend range in extremes also. Those transformers are very difficult due to vibration point of view, due to small size, low weight,
It's very very complex transformers. The concept is similar, transformer concept is similar, but with respect to the in surrounding things, it is very difficult. Yes, some starting transformers for motors and all, some transformers are required for starting. The considerations are little bit different. Some testing transformers. There are some cases where transformers are required for testing places. For example, for testing transformer itself, we need another transformer. Those transformers are completely different. They need a tapping range very huge, say some 30% to 30% in steps, maybe 20 steps below, 20 steps above, something like that. Otherwise, they may need dual voltage 6 kV or 12 kV like that. Huge range will be there. So those transformers are not covered here. Some welding transformers, they are also very different. So those transformers are not covered here. For example, dry type transformers, they covered in 11171, something like that. So from now onwards, I just read headings only. A few things I may study, because to save some time, it may take more than 1.5 hours if I go detailed. Yeah, service conditions I already today explained you. Altitude and all it will mention here. Maximum altitude is 1000. If it is beyond that, we have to take some correction. Temperature. Ambient is -5 to 50. If it is going more than 50, some correction is required. See, if it is a water cooled transformer, 30 degrees is the condition. Yes, these are some other wave shape of voltage, approximately sinusoidal. Yes, here you can see 5% of total harmonic content and 1% of even harmonic content. Yes, this is also most important whenever it is not sinusoidal, that is what sinusoidal supply. If it has some more harmonics like that, then the limit for that harmonics is 5%. Sometimes the shape for even wave is not same as above upper part and lower part are not same. In that cases we will have even harmonics. Here you can see 1% for even harmonics. I mean second or fourth or sixth, those harmonics generally it won't be there, because most of the times it will be same. We have alternators and all. For example, we have for alternators we have some poles, fields and all. When say like this, whenever they are applying some field, whenever this is rotated by some turbine, electricity is getting generated. Whenever, for example, some pole is getting damaged, something damage is there in this pole, so at that time we will get even harmonics here. So that is one thing. Symmetry should be there. That's what even harmonics related. Installation environment, it should be normal. It should not be something unusual. Something unusual means we should take care seismic, like higher altitude, higher low temperature, humidity may be high, seismic activity, contamination may be high. You have to take care of bushings and all, painting and all, overloading, load current curve. These things we should take care for flux density or current density, whatever values are there. We should take care for that. Yes. Shipment, storage, yes, there are weight and space limitations are there. There may be some special conditions. We can refer these standards for other things. Yes, generally, power transformer, they mentioned some definitions: booster transformer, oil immersive transformer, dry type transformer, oil preservation. For oil preservation means, for example, this is the transformer. How we are preserving the oil? Say, if it is a highly overloaded, oil may come out. So we are placing some conservator here, so to capture that. If it is a completely sealed system, it is like this only. We are providing some gas cushion. If it is completely filled, we have some ribs here, corrugations like that. They will just, it is completely filled with oil. So what it will be, they will just take the expansion contractions. So this is one type, this is another type, this is another type. In power transformers we will have air cell also, that is fourth type we can say. Sometimes say for example, this is a transformer, here main conservator, here is a OLTC conservator, this is some fifth type we can say. These are some different oil preservation system. These are terminals. Generally EVW, RYP will be the terminal, neutral point, windings. Windings means I think you are aware of that. Say for example, this is the transformer core. I'm just trying single phase. Say this is one LV winding. otherwise this is HV winding. This is what our textbooks discuss, but practically we are not doing like that. Say for example, this is the core. Here only, for example, one is LV over, we are directly winding HV winding. In this limb also similar way. So half winding here, half winding here. So this is LV comma HV. Similarly LV comma HV. Like that we have windings. A tap winding, for example, say this is the winding like this. Just to take care of voltage variations, what we are doing is, for example, we are just adding some extra turns here into the circuit. That's what tap winding. Phase winding, that's normal. High voltage winding, low voltage winding. One is high voltage, another is low voltage. Intermediate winding. Whenever we have, say for example, star-star connection like this, to take care of harmonic or something, we may have intermediate winding, another voltage winding, tertiary winding, something like that. So we will go to the details later. Auxiliary winding, that is for supply in traction, you can have stabilized winding. Yeah, that's what I am discussing about. Delta. Common winding, series winding, these are for auto transformer, common or series. Energized winding, yeah, this okay. The rated quantities, these are all normal. Rated voltage of winding, these are all normal. Rated voltage, frequency, power, yeah, current, rated current, single phase of. Here is the tappings. Yeah, to take care of variations we will use tappings. We have plus tapping, minus tapping, tapping step and tapping range. How it will be there? Here tapping duty. Yes, these are all normal only. Full power tapping. Almost we will use full power tapping only. Reduced power tapping, very rare cases. No load losses and no load current. Yes, when there is no load in secondary. For example, this is the transformer, one side, other side. There is no load, for example, zero load. Whatever the current it is drawing to make it magnetizing, that current is, we will call it as a no load current. Just the losses are whatever losses are coming, no load voltage, no load losses. When load is there, say for example with something, then at that case load loss will come into picture. That together is we can say total losses. No load, yeah, load loss. Short circuit impedance, whatever impedance is getting dropped in this winding, that we will say some X. Yes, that what leakage reactance. Yes, here that what we are discussing here. Zero sequence impedance, temperature range. Just whatever the material we used for framing this conductor, it may get heated due to the temperature, right? Temperature developed in the winding. So we should choose proper cross-sectional area of conductor, otherwise it may rise more temperature. Generally in IEC or IS, 250 degrees is the maximum temperature, generally for aluminum or copper. For both windings, I think for copper, for aluminum this should be like this. This is for copper, yeah, 250 or 200. So we should choose our current density or the conductor size accordingly, so that in worst case, for example, I naught by Z, this is the worst case current. Whatever current fault current flows, if this current flows for 2 seconds, our winding should not reach 250 degree. That's what temperature rise defines. Star connection or delta connection, that is based on requirement. Open zigzag connection, this is generally used for providing a earth connection like that. It is open windings. Yeah, connection symbol, yes, generally some symbol will be there. Say DYN 11, D means like this, 11 means you know, right? Why this is like watch, so something like that, DYN 11. So type test will be there, special test will be there. Rated power means what? There are some loading cycle, generally it is like normal cycle only. Preferred ratings, yeah, this is the R10 series, that's what we are discussing about. R10 series means it is a geometrical progression. 100, 200, 160, 200 kV, 250 kV, 315, 400, 500, 630, 800, 1000 like that. It's the cycle repeats again. 1250 kV, 1600, 2000, 2500, 3150, 4000, 5000, 6300, 8 MVA, 10 MVA. Cycle repeats. 63 MVA, 31.5 MVA, 25 MVA, 20 MVA, 16 MVA, 63 MVA, 80 MVA, 100 MVA. Yeah, like that. Those are some preferred ratings. That's what standard rating says. Yeah, these are all normal. Here you can see the constant flux, variable voltage, variable flux, variable voltage, CBVB. Yeah, these are some different aspects. Yes, our flux is always constant in our transformer. V by F is always constant in regular transformers. This is what they are just discussing about tapping related. Yeah, we will discuss more in future sections. Yeah, here load loss temperature. Whenever we are doing temperature rise, generally plus or minus 5 taps, plus or minus 5% is there up to 2500 kVA. So if it is more than 2500 kVA, the negative amps are more, so we should do at negative tap only the temperature test. If it is plus or minus 5 below 2500 kVA, the rated tap is okay for doing temperature rise. That's what the discussion is here. Yeah, this is what phase display vector displacement yn. First letter is HV, generally second letter will be the L. If we have intermediate, we can use that. Yeah, that 11 means 11 into 30, 330 degree. 330 degree lagging will be there with respect to primary. This is what clock. We will discuss more things in our future slides about this vector group and all. Yeah, so additional information here applicable. So some extra information customer has to give. But for example, this is the rating plate. Manufacturer name should be the year of manufacturer, power or capacity, connection symbol, frequency, rated voltage, short circuit impedance, total mass of oil. Yeah, these are some aspects here. ONAN, ONAF. These are some aspects that must be followed by manufacturer while when printing the rating plate. Yeah, here some other things. Yeah, we can see it here. The ratio 0.5% plus or minus 0.5% ratio error. The losses are 10% for total. Individual losses can be 15. For example, no load losses can be plus 15%. The load losses can be plus 15%. But together can be whatever we declared as the sum of them, 10% only applicable. That's what this says. But yes, that purely depends on customer. Nothing is required to do. Yeah, here is the tapping. Generally, plus or minus 10% tolerance is allowed. If impedance is greater than 10%, then 7.5% only tolerance is allowed. That's what the standard says. Yes. So remaining all things are very normal. Nothing else. Reference temperature generally we will use 75 degrees centigrade for oil field transformers. For dry transformers generally whatever rise is there, rise plus 30, otherwise rise plus 20 in IEC, something like that we will use. I think this may be ECBC, like that we will use. These are some different tests: winding resistance, voltage ratio check, short circuit impedance, no load current, no load loss, dielectric test, tap changer is there, tap changer test, temperature and dielectric test are some special tests. Generally impulse will come into this category. Temperature rise, that's okay. Even though test is not there, as a manufacturer you should comply everything. That's what good manufacturers will do. Yes, these are some different aspects, sound test and some other TV. Yes, winding resistance, short circuit. Yeah, these are all normal. I'm not going to the details that much because it may take more time for us. Yes. This is what some other standards they are referring here: temperature range, insulation, terminal marking, ability to withstand short circuit. Here we have some other data. Just go through the data. These are some normal information. Parallel operation. What job we can do parallel operation? Here some conditions they mentioned. Here some more details are there. Some examples. Short circuit impedance by boundaries. Yes. Here we have connection groups. What connection group we can do? This about these connections and all we will discuss in separate section. How we can decide what connection is important, what connection is required for us, which one we can choose, whether YY6 is required or YY0 is okay, or DY1 is required, or when we will you go for DY11, DY11 like that. Yeah, we will discuss all this stuff in our next session. There are different vector groups. Yeah, this is what temperature correction. Generally, temperatures whenever we are taking recordings, before energizing it may be normal 20 to 25 degree like that, but we have to convert that to 75 degree for making losses. So we will use these formulas for conversion. For aluminium, this is one coefficient. For copper, this is the 235 different coefficient. That we will use for regularly for I square R losses, I mean resistance conversion. But for stray conversion, we should use this formula in a reverse manner. Yes, we came to end of the session. Thank you BIS for providing me this standard online freely, so that I am explaining here. Many of the young generation, many of young engineers get benefited with this. Yeah, this is what guys. You just go through this standard again, like the steps I followed. I hope you enjoy this.
This is the explanation for part 1 only. If you need any other parts, so please subscribe to my channel and watch all other parts 2 to 11. Thank you. Thanks for watching. Stay connected. If you have any questions or comments, or if you need any further info on any topic, please comment in comment section. I am ready to help you. Thank you. Bye bye.